Good morning,
Hey,
David. Yay, or afternoon. I guess it's after 12 now. So
afternoon. It's
cool.
now afternoon.
Yay! Yay, cool. So, good afternoon, everybody, and thank you for dialing into today's San Francisco Bay Area PostgreSQL Users Group Meetup. It's April 13, 2022. Our speaker today is David Ventimiglia, talking to us about Hasura GraphQL for PostgreSQL. Just a few notes first. This meeting is being recorded and will be posted on YouTube afterward. If you choose to ask a question, your voice and your image, if you have your camera on when speaking, will be part of the recording. If you do not ask a question, you will not be part of the recording. If you are using the most recent version of the app, which we recommend, you can use the raise hand function to join the queue for the Q&A at the end. This function is maybe available in the web browser version, maybe it isn't. Sometimes it seems to be, sometimes it isn't. If you're using an older version of the app or a web browser which does not have this function, please use chat to let the organizers know that you would like to ask a question, and we will add you to the Q&A queue. The organizer will let you know when you are next in the queue, so you can be ready to unmute your microphone and ask your question. You can also simply type your question into the chat. We'll convey it to David, and then he can answer it. We will be doing Q&A at the end, so please hold on to your questions until then. If you have any technical issues during the presentation, please message the organizers for assistance. If you get kicked out and can't get back in, please post a note on the meetup page for the event. We're watching that during the event as well. I'd like to thank our sponsors, United States PostgreSQL Association, aka PGUS, doing our part to create community in the Postgres community in North America and wherever else people are interested in being community. As a disclaimer, I am the president of the PGUS board, so I'm not entirely unbiased here. I'd also like to thank our other sponsor, PGX, PostgreSQL Experts Inc., for the organizer time and for creating and managing the videos in the YouTube channel. Again, disclaimer, I work at PGX. So having gotten all the business out of the way, I think now, I would like to introduce David Ventimiglia, who is our speaker for today. David, I'm going to make you the presenter.
Okay.
And it's all yours.
Awesome. And I will share my entire screen. And please let me know if you can see my screen, which right now is GoToMeeting.
Yes, we can see it.
Can.
And yes.
Great. So if it's all right, I'm going to jump over to my slides.
Let's
and
do that.
introduce
Perfect.
myself, which you've already
Great.
done, but I'll introduce myself again. So this talk is Hasura GraphQL for PostgreSQL. That's a lot of S's, Q's, and L's. Subtitled The Voyage Home, which is really just an homage to the Star Trek movie from 1986. And I'm, as I said, and as Stacy said, David Ventimiglia. So who am I? I'm a physicist, former physicist, a data scientist, data engineer, and software engineer. I work for Hasura, a software technology company that provides developer-focused tooling products. And as a personal opinion, one of my mottos is I believe that the best code is the code that you don't actually have to write. And I can be found many places, neptunestation.com. That's my personal website, but I'm on all of the usual channels as well, and I can make those available to people if they need it. So what are we going to be talking about today? We are talking about Hasura, which is a product provided by the company that a disclaimer, I work at Hasura. And on the tin, one of our marketing slugs for this product is, from your databases to a unified GraphQL API in just 1 minute. So wait, what? What is that? Let's break that down. What does that mean? So a primer for folks who've not seen or heard of GraphQL yet, maybe a review for people who have. GraphQL is a web interchange format. It's a API specification created by Facebook. It is in some ways an alternative to REST, which I hope everyone is familiar with now. An alternative to REST and maybe a successor to REST-based web endpoints. It is a query language. The picture on the right of the screen, that gives you a flavor of what GraphQL looks like. The left-hand pane is a GraphQL query. This is a document. It looks like JSON, but it's not quite JSON. It's a GraphQL query document that is sent to a GraphQL server over HTTP. And in that document, you express a query whose purpose is to specify what it is you would like to retrieve from the backing data source. And one of the ideas is that the shape of the GraphQL query resembles the shape of the data that you will get back. As you can see on the right, what you get back is a JSON document. So in this case, this query is for users, some attributes of users, and their addresses, and those data are coming back in nested JSON fashion. So GraphQL, it's a query language. It has a spec. That spec defines a number of concepts, but key concepts are there are schema. Within schema, there are types, which are ordered collection, or the server will provide ordered collections of instances of types, and those types will have fields, and types can relate to each other through those fields. So for instance, in this example here, there is a user type, there is an address type. The user type relates to the address type in a one-to-many fashion. And hopefully that will sound familiar to folks, kind of like SQL. So Hasura GraphQL gives you, what did we say? We said it gives you, from your databases to a unified GraphQL API in just 1 minute. So how are we doing it in just 1 minute? Well, it's a server. You provide it your database credentials. You point it at your database, PostgreSQL, and it will introspect that database, and it will generate a GraphQL server for you in just 1 minute. Going back to this slide just for a minute, if you'll allow. Anyone who's familiar with GraphQL, or if you've encountered it, or if you've worked with it, of course, a common concept that comes up is, another term that you will hear is resolvers. So a little bit of backstory. Among the motivations for GraphQL is, in principle, to help the consumer, help the API consumer. Let's say that's a user interface designer. So rather than having to call some number of REST endpoints, perhaps stitch them together in series, perhaps not getting all of the data that you need and getting more than you need in some cases, you can express precisely the query that you need to get your data, and then you're off and running. Of course, that sweeps a lot of details under the rug, and it shoves some burden onto the back end. There still has to be a server that manages all of this. And so a common way to produce GraphQL servers in Java or any other language is to write resolvers. So these hierarchical, these nested GraphQL queries and the data that they retrieve, for each element or each field, there will be a resolver. So there will be a bit of code that is a resolver for a user, and then that will delegate to resolvers for ID, name, email. Some of those resolvers are simple. They just return a simple scalar, like a string. But then some of those resolvers will then have to further delegate to something that will get, say, the addresses, the address resolver. So there's always this concept, there's often this concept in GraphQL server writing of writing your resolvers. How are you writing resolvers? What are you using to write your resolvers? Well, Hasura, of course, recognizes that there is, of course, this broad similarity between GraphQL and SQL, and so it will, it essentially is it's a transpiler, it's a compiler. It will take the GraphQL query, again, that we saw here on the left, and it will convert that into a SQL query that it will run against your database, PostgreSQL, generate the data, marshal the data back, do some light processing, and return it to the client. This picture just hopefully helps situate Hasura within your infrastructure. This is a very simplified diagram. the left, it's sort of very similar paths. On the left, Hasura sits in the middle. You have your app on the bottom. It will connect to Hasura over HTTP, and then Hasura will connect to a database, in this case, a single Postgres instance. And along the way, Hasura has quite a few other features. So along the way, it can reach out to an auth provider, provide auth tokens, say JWT. Your auth provider will validate the claims that are within that, return session variables, which then are sent to Hasura, which is then used for things like authorization and other activities. On the right, it's pretty much the same picture. This is just illustrating that Hasura actually can connect to a variety of backends. So you can connect to one database, one Postgres database. You can connect to multiple databases. You can connect to databases and other downstream GraphQL services. And Hasura will, provided that you've given it the data to do so, it will merge those data, it will join those data and blend them and send them back to the client. Of course, this is, again, a simplified picture. In practice, besides the app and Hasura and your database, you will also have web application firewalls and API gateways and load balancers and caches and maybe some sidecars. But these are the main components. And if you look at this, Hasura is essentially, it's an application server. It's like many of the other things that we're familiar with, Ruby on Rails and Apache Tomcat and Microsoft Transaction Server. So that's the high-level picture of Hasura. Okay, so why are we doing this? Well, if you'll indulge, I'll take a hopefully brief stroll down memory lane. So, moments in history. A long time ago, there once was a time where we had two-tier technologies. Let's say back in the 80s and 90s. And by the way, these dates and some of these technologies are notional. They are one point of view. They're, excuse me, my recollection of events. But my memory is not quite what it used to be, or at least I think it is. Hasn't been. So if anybody wants to quibble with these, that's fine. But it just gives you a flavor of some of the things that we had. So we had thick clients, Visual Basic or Power Builder or what have you, that would connect to the backend, the server, the database. Back in the 90s, I worked on one of these products, which was a CRM application. It was a thick client in Visual Basic, and it talked directly to Microsoft SQL Server. And the whole backend was written in stored procedures and SQL. And we had to know SQL and stored procedures and transact SQL pretty well back then. But then, time moved on, and two-tier begat three tiers. So we sprouted a new tier, and the proverbial business logic started to move out of the database and into this middle tier, be it Java Server Pages and Enterprise Java Beans, or ASP Pages and Microsoft Transaction Server, or Perl. There might be an object relational mapping layer thrown in there. And I think we all remember that. So, we started not really using the database quite so much. And if you'll allow an editorial aside, we started to develop some sort of fear and uncertainty and doubt about the database. So moving on, if three tiers is better than two tiers, then n tiers is infinitely better than three tiers. So we added business logic servers and messaging queues and lots of caching and data. And again, the details, we don't really have to dwell on it too much. And all of these things are valuable and worthwhile. But again, so to speak, the business logic was still somewhere in the middle, in Ruby on Rails or in Spring or in Java or in C#. Then we moved on to service-oriented architectures, which is fine. Things got a little bit more complicated, but a little more formalized as well. But we still had business logic in the middle in Java and say Spring. Then we moved on to microservices, and you know the picture. This was good, but this is probably this was sort of the high watermark of operational overhead. There are a lot of moving parts involved here, but fortunately, some things came to the rescue. We started to sort of the parabolic arc of complication turned over, and we started coming back in the other direction. We started simplifying things by shoving a lot of the details into Docker, and cloud became available. We could start shoving concerns onto AWS. Things are getting even simpler, maybe, with things like Amazon Lambda functions or Cloudflare workers, where you don't even have to deal with a server anymore. But all along this path, you're still dealing often with the database. Often that database is a relational database, and often there is still SQL on the back end, but we're really, in my experience, really not using too much. And so that's where we come to here. This era we are in, we might call a low-code environment with things like Firebase, or as in this talk, Hasura, where we have a UI which is in React or Flutter or whatever, and we are now we've now reduced it down to just Hasura in the middle plus Postgres, and as I'll show you, we are in a position to start once again leveraging the power of the database. This is where we are. This is maybe another place that we are, from low code to no code. Folks are starting to build applications, not even with a database at all. They're just building, or even with any code. You might use something like Glide, where you can get mobile apps just on spreadsheets, Google Sheets, or Airtable, and where Airtable is a cloud database spreadsheet hybrid offering. And maybe in this environment, maybe there once again won't be any SQL code, and maybe there won't be any JavaScript or TypeScript code. We'll see, but maybe we're not there yet. Maybe we're still back here, and I think we are. So that hopefully sets the stage. I will take questions as I get set up for a demo, although, again, happy to take questions at the end as well. I'm switching over to, if you'll forgive me, to here's Emacs, and then another tab within my browser, which is, so I hope folks can see this. This is Hasura Console, which is a web application provided by Hasura. Again, Hasura is a server. It ships as a single Docker container for ease of deployment. Hasura is an open source product, or project rather. All of the features that I'm showing you today are in the open source project. These are all functional concerns. Hasura, of course, as a company, we provide an enterprise product that has non-functional concerns, things like caching and analytics and rate limiting, but that's not relevant to what I'm showing you today. But again, anybody can grab this. It's up on Docker Hub. It's very easy to deploy. And hopefully to prove that, allow me to go back to Emacs. Now this is all running on my laptop from a Docker Compose file. I hope folks are somewhat familiar with Docker Compose. Docker Compose is just an easy, convenient way to launch multiple Docker containers in concert and orchestrate them together. So even without knowing exactly what Docker Compose is, I think it's fairly straightforward. What's happening here is we are launching some number of services on my laptop. There is an instance of PostgreSQL with that image, version 12. There is one instance of the Hasura GraphQL server with provided by this container. This is version 2.4. These being Docker containers, we're doing some port mapping from internal ports of the containers to external ports on my laptop. And these containers running in this orchestrated environment have access to each other. So for instance, there are environment variables provided to Hasura, and as you can see, one of them is two of them are database connection strings. So this is referring to the Postgres user with that password on the Postgres instance, and that of course refers to this database, Postgres here, which has been set up as part of this Docker Compose file. There's a process for bringing all this up. The output, just to show you that it's real, is here. So these are just the logs of all of these different services. Postgres is coming up, and GraphQL server is coming up. And so those are the two main services, containers, images that are involved. There are a few other services that I've added at the bottom. Maybe we'll come to that at the end. But that's what's brought up these two servers, Postgres and Hasura, on my laptop. Having brought up these two things, I then have a SQL client. This is PSQL connected to that database. Right, so connected to my laptop on this mapped port 5433. Then the other service, which is Hasura, is providing a number of functions. One of them is this GraphQL API that I described earlier. The other is a web client administration console, which is shown here. And it has a variety of tabs, but the one I'll focus on right now is the data tab. And so what's happening here, this is where you tell Hasura about your database. So as you can see here, I have already connected one Postgres database, and I've said there are several ways that you can do this. You can either provide a connection string, you can provide connection parameters, or you can use an environment variable. And in this case, I'm using the environment variable pg database URL, which was provided to Hasura in the Docker Compose file. But those details aren't hugely important. The point is that by pointing Hasura at my database, it has introspected that database, discovered the tables that are available, and it offers to do something that's called tracking. You can track a table, and when you track a table, that means that it becomes exposed as a type in your GraphQL endpoint. So obviously you might have many schema, many tables. Some of them you do want to provide access through this API endpoint, some of them you don't. And so those tables are listed here on the left, and Hasura provides some details about those. Let's see, starting from the top, we can, there's a lot going on here, of course, but like, so for instance, I could untrack this table and then Hasura would forget about it. I can retrack the table, and this just gives you some flexibility in how you present this table as a type through GraphQL. So Hasura is, again, it's tracking tables, and then for those tables, it's providing a GraphQL type, and then we can start making queries against that GraphQL API, and of course, it's then getting those data from our database. The other, or another thing that Hasura can do, and that's why, well, another thing that it can do is, as I mentioned, it can reach out to other downstream GraphQL servers. and that's on this Remote Schemas tab. And I've already configured this. So let me back up. For this demo, I thought, well, what am I going to do for a demo? So I did the usual thing, which is I said, well, I want to showcase its ability to connect to remote schemas. So why don't I grope around for some remote schemas? So I Googled, and I found this page that had, helpfully, a variety of publicly available GraphQL endpoints. And there is a handy weather API. You can try it. There's a repo. You click the repo, you see that this very nice person has built this GraphQL service, which is really a wrapper for a REST endpoint that gets weather data. If you click the Try It button, it will launch a GUI interface. Now, just to clear up any confusion, this is not part of Hasura. This is just a common aspect of many GraphQL servers. They may provide a graphical client, and this one does. You can see the endpoint up here. Clearly, it's running on Heroku. In the documentation, the author of this says that there are 2 top-level queries that you can perform. You can get information, weather information for a city by name. You can get by ID. We don't know any IDs, but we do know names. So let's start running some queries. So we say, well, another important detail about GraphQL. So because GraphQL has a spec, because the queries are highly regular, and because it's based on types, it is possible and even easy for those data to be machine readable. So often, GraphQL servers will export all of the data about the API as the results of an introspection query. And then tools, there's a lot of tooling. There's a rich ecosystem of tooling that has sprung up in the GraphQL community to support this. So this graphical client, for instance, on the right, there is helpful documentation on all of the things that you can do with this API, all of the queries that you can perform, and all of the types that it provides, and all the fields that are available. Moreover, this tool will, and tools like this will do autocomplete. So for instance, it was easy for me to type out this query because in any of these types of editors, control space will just give you a list of the attributes that are available. Now, of course, you can do this with REST as well, with Swagger and OpenAPI and others. I don't want to say that this is only a GraphQL thing, but it is a nice attribute of GraphQL, and it makes writing these queries easy. And so I've done this here. And you see here I'm getting weather information for Oakland. So let's run this. And it says there's moderate rain in Oakland, apparently, which is hard to believe because looking at my window, it looks sunny. But in any case, so these are the data provided by this downstream service, and they are identifying these cities with a numeric identifier. Okay, so that gives us a clue. So I take this, or I have taken this endpoint, and I have plugged it into Hasura as a downstream GraphQL service that I want to pull data from. And part of the reason I thought, well, okay, if I have a weather API, maybe I could build something like Nomad List. So this is a popular website that crowdsources data on locations throughout the world with user-generated feedback to give you things like, besides images of cities, also you can see that there is weather information provided there. And if you click here, people have provided or can provide reviews of locations. So I thought, okay, this might be a nice, maybe we could, do a simple version of Nomad List where we pull data about the weather and maybe other aspects of locations. And then we merge that, or we blend that with data in our Postgres database, things like reviews of those cities. So the first step was, as I said, to bring in this downstream GraphQL service in Hasura. You can see that we've provided the URL. We can do some simple modifications to it if we like. We can apply permissions if I had set the environment variable, but we won't deal with that right now. So having done this, immediately Hasura, like that client that I just described you, it will also reach out to the downstream service, get its schema, introspect it, discover everything that's available, and then present it to its consumers. So right immediately, if we go over to the API tab and we click, we have our own. So Hasura has a graphical query environment, much like the other one that I showed you earlier. It also has a docs tab. And in this docs tab, you can drill down into the types that are available. Click on query root. We see, ignoring some of these other aspects, we can see, aha, here's get city by name, which is exactly the same query that was available here and is also described in the documentation provided by this person. So great. We're reaching through Hasura and we're able to get those data. You can see that with if we get city by name, it gets a city, and then from a city we can get the weather, and from the weather we can get various attributes. Okay, so that was step number one that I performed, was to add that remote schema and bring those data in. The next thing is, as I said, I wanted to join those data and enrich them with data in my Postgres database. So I created some tables. And that's where we come to the data tab. So you can see that there is, now these are tracked tables. There is a city table, and it has the column, as reported in Hasura's admin tab, its columns has an identifier, primary key, usual housekeeping field, traded at, updated at, and then I've added a relating field, city ID, which is text, but I'm using that to store the this value. So we know that this service, this downstream service, seems to have a numeric identifier, but we can just treat it as a string, and that's what we're going to use as a join field. So I've added that into my table. Now, this probably looks unfamiliar to you in terms of as a way of examining tables. So if we like, we can go back to SQL and we can say, well, what tables do we have? Well, there are those tables. Let's look at the account table. Well, actually, let's look at the city table. Right. So there's our ID, primary key, the UID, the housekeeping field, traded at timestamp, and then there's this relating field, city ID, which is text. And I've already done this. I've already pre-populated these data. City, you can see that there are, besides the UID, primary key, and housekeeping fields, here are these fields. 5391959 is, I guess, it's one of these cities. It's probably San Francisco or something. Anyway, so that table is there to act as a linchpin, a way to relate our local data in Postgres to these downstream data in GraphQL. Okay, so we've got our city table, and I could adorn this, and in fact should adorn this city table with other attributes, but so far these are the main ones that it has. Related to that, there is an account table, because we imagine that at some point in the future, users will want to create accounts and log in and start supplying user-generated data. I've added, besides housekeeping fields, primary key, timestamps, there's an email field and a name field, which is text. This does illustrate just one tiny little detail. So one of the ideas is, harking back to my stroll through history, is to start to bring some of this proverbial business logic back into the database. So in this, to illustrate that, or an example of that, I created one domain to validate emails against this expression. And as you can see, the email field on the account table it has that domain type. So that validates, or at least the goal is to validate emails. So of course, you can imagine doing this in Java with a regular expression, or in Perl, or in Python, or in anything else. And often that's what you would do. You would write business logic in those languages, but you don't have to. And it would be nice if you could start to do these things in the database and then have some way of exposing those to consumers, which is what Hasura provides. In any case, we have this account field, or this account table rather. And if I pre-populated that with some fake names, Gloria, Talia, Andre, Jim, and then ignore the random city. Random city is a view that I created just for fun, just to grab a random city. But then there is the review table. So this is the primary place where we start to add some user-generated data. So again, primary key, housekeeping fields, a relating field, a city ID, which, as you can see, has a foreign key back to our city table, our linchpin table that then connects us to a downstream service, and then body, which is where we'll place our review. If we select star from, there are, besides these housekeeping fields, there are reviews of cities. Reviews say things like, whatever the city is, it's either cold and windy, or it's windy but fun, or it's a paradise. We can guess that the bottom 6 are probably Lisbon. They're all written by me. So those are the tables as viewed through Postgres. We go back to Hasura. I have tracked all of these tables along with this view. If we look at the review table, you can browse the rows in it. You can see it's the same data that we just saw. Okay. So just to reorient ourselves, we have important detail. Within Hasura, there are something called relationships, which is just, it's Hasura's way of knowing. We've said that we track tables in Hasura. We also want to track relationships between tables. Unsurprisingly, relationships are typically built on and modeled by primary key, foreign key relationships. In fact, if you have primary key, foreign key relationships in your database, Hasura will guess that those should be relationships, and it will offer to track those for you. Here we can see, if we look at the account table, and we look at its relationships, we see the account table has an array relationship to reviews, or it's in Hasura speak, or in GraphQL speak, it's an array relationship, but in database parlance, we would call that a one-to-many relationship. If we look at review, on the other hand, it has an object relationship to the account. That's the account of the person who created the review, and has an object relationship to the city, which is the city that this review is for. These are one-to-one relationships. And it's by way of these relationships that are tracked in Hasura that we can start to stitch together this proverbial graph. So having done that, we have so doing that populates our schema with types and relationships. There's an Explorer tab on the left, which is just a handy way of building queries by clicking if you like. But we can also just write them by hand. So we can start to say, well, let's do a query. Control space. What do we have available? Well, we could just do get city by name, and we'll specify it. So get city by name is a field, but fields can take parameters. This one takes a name. All of this is being auto-completed or suggested by the interface. So we'll say Chicago. And then we say what fields we want back. And we want the name of the city and weather. Weather is a complex type. So what we want is a summary, the description. Maybe that's enough. But remember, this type this by itself is satisfied by that downstream service. So when we call this query is going to Hasura. Hasura is passing it on to that downstream service, which I hope is running, and it is, and it says, great, there's overcast clouds. So at this point, we've not merged this with any data from our Postgres database, but we can do that by writing a different query. We can say, well, let's say that we want a review. We want reviews of cities. For those cities, we do want the weather. The weather we want double name of the city just to make sure we have it. So this is the name of the city is in that downstream service. I should have a copy, or there should be a representation of the city name in my local Postgres database. Out of sheer laziness, I haven't done that, so that's why we have to reach to the weather service to get the name. But we're getting the name. Actually, name is not a complex type, but we are getting the actual weather, which is, let's say, the temperature. But recall, what we want is we want the review and the weather together. So the review has the body text, and let's say we want the account, the person who wrote that review. Run this, and it is getting us, let's see, it's getting us array. It's getting us everything. We haven't provided any filters, but we have New York, we have its temperature, and we have a review by this person who she says it's a city that never sleeps. And so on and so forth with, looks like she wrote a review of Ho Chi Minh and quite a few other places as well. But the important point, or the point that I want to stress here, is these data are being merged from Postgres, running locally on my laptop, and this downstream service. Postgres has the account data and the review data. The downstream service has the weather data. But from the point of view of a consumer or a client, there's very little difference. It all gets merged together. So that is how that is done. And let's see, what else can I show you? Okay, just a few more. Hasura has many product features, and I don't have time to show you all of them. I will show you a few others. If you'll note, so we're passing along request headers, accessor role, accessor user ID. So these would be part of the request to Hasura. The Hasura user ID would have been injected into the call by having, so the client makes a request to Hasura, provides, say, a JSON web token. Hasura, through a configuration that I won't really get into, but it will reach out to an auth provider. That auth provider will validate the JWT and the claims within it and return XSR role and the XSR user ID, which identifies this user. This UUID is the ID of some user. And that can be used within Hasura. Hasura, one of the features that it provides is fine-grained authorization or access controls if you want it. So if we look at the review table, we've looked at this before. We've seen its fields, we've seen its relationships. There's also this permission tab. So what we can say is, so backing up, there's two headers here. There's the role and there's the user ID. Role is a coarse-grained factor in authorization. This person is a user. They might be an admin or they might be a read-only user, and that will govern coarse-grained access to tables within Hasura. But then a fine-grained factor in authorization is the XSR user ID, which identifies that particular user. And again, that comes by way of your auth provider. That gets used or can be used in fine-grained access control in Hasura if you want. Through the permissions tab, we can say, well, we can start defining these roles here on the left. There's an admin role. The admin role is used if you are an admin. Either you are authenticated as an admin, or in this case, because this is a simple setup, if you, in the simple setup that I had, if you don't provide these tokens, then you are just automatically admin. But in any case, the admin has insert, select, and update, and delete full-blown privileges on this table or on this table review for everything. But there is also a user role, and these little funnels indicate that there is some kind of fine-grained permission going on. So what we've said, if we click on insert, if we look at the row insert permissions, we can either say no checks, so this person, this role has full access to insert in this table, or we can do a fine-grained permission check. The fine-grained permission check being done by Hasura, it will say, well, let's check that the account ID attribute of the field in question matches this X Hasura user ID. So we go back to browse the rows. We see that these reviews, of course, they have an account ID, which relates back to the account table. These are the identifiers of these users. So what this is saying is essentially users can only insert reviews under their own identifier. Like I can't, as X Hasura user ID 12345, I cannot insert, I'm not allowed to insert a review with an account ID 6789110 for any other person. I can only insert reviews for myself. Likewise, select permission also applies fine-grained permissions and says, hey, not only can you only insert reviews for yourself, you can only read reviews that you have written. Now, in practice, this is not really something you'd want to do with reviews, but this just illustrates how this works. So if we go back to query and we say, if we run this, we've passed X Hasura user ID A3960613, whoever that person is. I think that person is Galia. So we are only getting reviews that this person wrote. So if we pass, let's grab a grab an ID of some other user. So that was Gelia. Let's try Gloria. We've written no reviews. So we're now changing who we are. We're saying that we are Gloria. If we rerun this, well, it looks like she did write some reviews. She wrote some different reviews also of Lisbon. That is fine-grained permissions. We can turn that off, and in fact, for reviews, we would turn that off. We go to data, and we go to reviews, and we say, well, it doesn't make sense. It makes sense for everyone to be able to read the reviews that are available. So we'll click permissions, and we will say, even though we have fine-grained permissions on insert, we will say that there are no checks on reading data. Now if we go back to run this query, we get reviews on many more cities. Than was provided just by this person. So that's how fine-grained permissions work. There are we're coming to the end of my demo. There are many other features in Hasura. There are other ways that you can inject business logics through things called events, which are like triggers, like database triggers. In fact, they rely on database triggers, but they reach out to external APIs. There are actions, which are similar. There are computed types, computed fields. There are subscriptions. There are many other attributes within Hasura. But I think that at least gives you a flavor of what's going on here. That's it for the demo for now. I'm happy to be interrupted by some questions. Otherwise, I will move on to right. So these are some of the product features within Hasura. We talked about the ones that have strike through are ones that we have talked about. Again, Hasura provides a GraphQL API. It also provides something called a relay API, which is it's another kind of GraphQL API, but it adheres to something called the relay spec, which has some nice properties. It also involves some trade-offs. We didn't talk about that, but that's available as well. We talked about using Hasura with Postgres. This is the Postgres user group. Historically, Hasura began with support only for Postgres, and to be frank, it works best with PostgreSQL. It works well with PostgreSQL. It works with pretty much any of the. There's sort of an efflorescence of Postgres compatible databases, which is wonderful. There's Aurora PostgreSQL flavor. There's CitusDB and EDB and TimescaleDB and quite a CockroachDB. There are others that I'm forgetting. Hasura being built initially for Postgres works very well with all of those products. But we've since added, or has since been added support for Microsoft SQL Server and Google BigQuery, and there are other databases coming. MySQL, for instance. There are, as I said, there is something called actions. Actions allow Hasura to call a remote webhook, like let's say a Amazon Lambda function as a response, as a way of handling one of the fields within your GraphQL API. There are remote schemas. I showed you those. In this instance, it was connected to a remote downstream GraphQL service. Slightly similar but slightly different is there also are remote, or there are, you can now use Hasura with multiple databases, and in the same way that I'm joining data from my database, my Postgres database, to the remote schema GraphQL data, you can also join data from one database to another. You can join data between multiple Postgres databases or Postgres and SQL Server, BigQuery. You can join all of those things against downstream GraphQL services. We didn't talk about event triggers or triggers in general, but essentially what that is an augmentation of Postgres's table triggers so that when changes occur on tables and those triggers are fired, it generates events which Hasura will then process by calling external web services. So it's a way for triggers in the database or changes in the database to have side effects outside of Postgres. You can call, again, a Lambda function or a microservice. We didn't talk about authentication so much. That's the process of processing JSON web tokens with an auth provider. I just said that it does happen, but that's the process by which we extract or we get these headers, which are then used for authorization, which we did talk about to some degree. So again, among the features that Hasura provides is fine-grained access control on your data elements through those headers. We didn't talk about database migration. So another feature that sort of got bolted onto Hasura is you can actually manage your database. If I go back to Hasura's console here, go to this data tab. These tables here, we can create these, of course, through our SQL client or through whatever migration tool we like, but we can also create them right through Hasura itself. If I go to the data tab, I can say, let's say in public schema, I could create a new table. And it's a kind of a WYSIWYG, if you will, editor for creating objects within the database. If you do this, Hasura will scribble down the SQL for these as migration files, which you can then store into your source control system, and Hasura will integrate that with that and provide certain CI/CD functions for applying database migrations. In that way, it's similar to like Liquibase or Flyway, if you're familiar with those tools. It's just another function that Hasura provides. And then all of this can be managed with a command line interface that Hasura has as well. There's a CLI. We didn't really talk about it, but that's available as well. So those are the product features. This is, again, disclaimer, I work for Hasura, but this is not exactly an advertisement for Hasura, more for a concept, which is auto-generating or auto-providing APIs, enriched APIs for databases, so that maybe some of the business logic that you might have written in middle, let me put it this way. In the past, you might have written a server, a REST server in Spring or in Ruby on Rails. And while you were doing it, you would have applied your business logic in Java or in Ruby or in Python. Hasura, by providing that API automatically, so you don't have to write the API. So if you're not writing the API, maybe you don't even write the business logic in Java or Ruby or Python, and maybe you just write the business logic in the database through things like check constraints and proper choice of data types, triggers, and what have you. So this idea is captured. There are other tools that provide this. There's another open source project, PostgreSQL, which is quite nice. It works very similarly to Hasura. There's another one, a product called Prisma, which is slightly different. It's a little more like an ORM, but it sort of works the same way if you blur your eyes. There's an interesting project called PG GraphQL, which is a Postgres extension so that Postgres can actually handle these GraphQL queries natively. And that's pretty sweet. Of course, for that to work, you still have to have some way of shipping, of providing access over, say, HTTP, and that's often where something like Postgres comes in. In fact, Supabase, which is a company that has a managed database, which is built on Postgres, they're the creators of PG_GraphQL, and they use PostgREST to make that available. Of course, you can use PostgREST by itself, and what it does is similar to Hasura or PostgreSQL. It auto-generates an API for your Postgres database, but in this case, it's a REST-style database. So this idea is out there. It's out there in a variety of forms, but it is well imagined by Hasura. So we're coming near, we're winding down, and so while folks are thinking of their questions, maybe I'll pose a few questions to the community. Sort of, what have we accomplished here? So if we take a step back here, like maybe this isn't all that amazing. Maybe this isn't all that groundbreaking. Again, I've said that we've taken GraphQL and we've transpiled it to SQL. Well, if you can do that, then in some sense, GraphQL must be isomorphic to SQL, which it kind of is. There's not really anything that you can say in GraphQL that you can't say in SQL, although the reverse isn't true. So why don't we just write SQL? Well, that might be nice, but no one really seems exactly to want to do that quite yet, although maybe we're turning a corner on that. So in the meantime, maybe we should be grateful that front-end users are if they're using GraphQL and something like Hasura or one of these other tools, they actually are writing SQL. They kind of just don't know it. So maybe we should just be happy with that state of affairs. But if we are, then we're probably going to have to accept some trade-offs, like we're going to have to start helping those developers write good queries and develop good data models and write good SQL, write good GraphQL. Because things like Hasura extend the power of SQL to downstream users, you can imagine you can get some poorly performing GraphQL queries that become some poorly performing SQL statements. And so there's some thought that has to go into how to do that well. So the question I pose, one of the questions that I pose to the community is, so maybe some of the ice is starting to thaw. Maybe folks aren't quite so adamant about always using Java or Ruby or Python, as nice as those languages are, and aren't so adamant about always using an object relational mapper. Maybe folks are starting to accept the idea of just slamming it right into the database, which is great. But if that's the case, then database professionals like the folks on this call are going to be needed to make sure that we all do it right. And that's all I've got. The QR code that you see here, I assure you that does not take you to the product page for Hasura. That just takes you to the GitHub repo for this talk, which has these slides and the Docker Compose file and all the code, and it should be runnable. I'm going to take some extra effort to make sure that's true, but anybody should be able to run this. So I thank you, and that's it. Any questions?
Great. Thank you, David.
You bet. Slightly over 1 hour, but
that's okay. It fits the time slot, so we're good. So let me just check and see if anybody's got their hand up. I don't see any raised hands. look over in the chat. Are there questions? I don't see any in the chat.
That's fine.
I think maybe it was so technically complete that nobody can think of anything to ask. Or
If
oh
only,
wait, no. Oh
if
wait,
only that
no
were
wait.
true. If only that were true.
No. Oh wait, we do have a question. It just came up. Suppose you want
Absolutely.
to get review. Yes. Suppose you want to get reviews of every city with sunny weather, assuming the weather API allows this. Does the call to the weather endpoint happen before fetching the reviews?
So you want to get, sorry, could you repeat the first part of the question? I think I understand it, but.
Sure. It says, suppose you want to get reviews of every city with sunny weather, assuming the weather API allows this. Does the call to the weather endpoint happen before fetching the reviews?
The call to, it depends. Let me think about this carefully. So if we go back to our API, if we had written, the way to think about this is if we start with, let's say we write a query, which is just get city. Let's suppose that downstream service had a query called get city by weather type. It doesn't, but let's suppose it did. I mean, a rough analog is get city by name. We can say get city by name and Francisco. And we're going to get the name, and we'll just be satisfied with that. So this gets run first and only by the downstream service. Now, suppose this only returns one item because there's one city. But suppose there was a query called get city by sunny weather, and it returned an array of cities that have sunny weather. Again, that would be run just by the downstream service first. Okay. There is, the issue is, so, okay, now I can answer your question. For these types of queries, the query would hit Postgres first, and the reason is the downstream service, so our types relate to the downstream service. Our service knows about the downstream service, but the downstream service doesn't know about our types. We can't say get city by name and then say get reviews. Because that downstream service doesn't know about reviews. We have to say, we have to say reviews, and then we could say city, and that's where we start to drill down into their weather API. So do what the person is asking is probably possible, but it would take more mental effort than I can muster under current conditions. But to answer your question, in this case, it would hit Postgres first and then the downstream service.
Great. And hopefully, Joe, that answers your question.
But happy to circle back on this question.
Yep. He says, okay, thanks. Yes. So you got that. Great. And let's see. Are there any other questions? Checking one more time. I don't see any raised hands. And don't see. I'm going to take back the presenter here.
Okay.
And I don't see any more questions in chat. So I think we are set. So great. Thank you so much, David. That was really terrific.
Of course. Thank you.
Appreciate the time. Absolutely. And then just for everyone's reference, let's see, what do we have next? So our next PUG is May 11, and we need a speaker. And perhaps that's somebody who's listening, or perhaps you can suggest somebody. and would love to hear from people. And let's see. Another other virtual events coming up, April 13, later today. The Chicago Postgres group, Henrietta Dombrovskaya, is presenting Norm, which is an ORM talk. April 20th, next Wednesday, Belgium. That's a virtual event, no worries. Ads Scherbaum is presenting What I Learned Interviewing the PostgreSQL Community, which if you see his weekly interviews with Postgres Person of the Week, you know that they're interesting and varied. And he also gave this talk at PG Day Paris. If you were there, you saw it, but it's an opportunity to participate. April 26th, in 2 weeks, Postgres users group Columbus, Keith Fisk is presenting extensions development in PostgreSQL. So those are some upcoming virtual pugs. In-person event, September 22nd and 23rd, PGUS is presenting PGConf New York, an in-person event in New York, 2 days. Very excited about that. The CFP is open until May 31st. Early bird registration is on as well. So that's all the upcoming events that we have currently. This video has been recorded. We'll process it once it's ready, post it on our YouTube channel. We'll email everybody in the meetup when the video is ready with the link. You can also watch our social media on Twitter and find the link there. Again, we're on Twitter at Bay Area Postgres. Go figure. Thank you so much, David. Thank you, everybody, for coming. We appreciate it, and we'll see you all in May. Take care. Bye.